Hello everyone, my name is Frans Marcelino Purba. Now I will presenting my presentation is topic is testing and inspection of metals, the quest for quality. Our supporting lecturer is Professor Dr. Tjokorda Gde Tirta Nindhia, STMT, Magister Engineering Metallurgi, Mechanical Engineering Study Program, Faculty of Engineering, Udayana University. Reference the first is Metallurgy for the non-metallurgy second edition by Arthur Sheridan. This topic is metallography, hardness testing, iron seal testing, fracture toughness, impact testing, fatigue testing, and non-destructive testing. Metallography. Metallography is a branch of material science and microscope that focus on the study of the microstructure of metals and alloys. It involves the preparation of the metal samples followed by the examination under a microscope to analyze the arrangement of grains, phase, inclusion, and defects with the material. Metallography plays a critical role in understanding the properties and behavior of metals, aiding in materials characterization, quality control, and failure analysis. Next is macrograph of the album iron meteorite prepared in 1808 by Count Wittgenstein and scrapes using heavy acting in electric acid. After rinsing in water and drying, printers was wrote on the acid surface and the sample was pressed onto a piece of paper. Next is hardness testing. Hardness, as the term is used in industry, may be defined as the ability of material to resist permanent indentation or deformation when in contact with an indented underrod. Generally, hardness testing consists of placing an indentation of known geometry and mechanical properties into the test material. Hardness testing may be classified according to various characteristics, such as the first is the type of indentation measured per moment, two is magnitude of the indentation load, and three is measure of the test. For example, the measurement of the indentation is used in the barrel, frickers, and crop hardness test. In contrast, indentation depth is measured during local hardness tests. Okay, is macro hardness testing. Macro hardness tests are commonly performed as an integral or part of quality assurance procedures. Brenner test the setup for a Brenner test in C shown in this picture and like figure A. Okay, the indentation is measured in millimeter shown in B. Hardened steel or carbide ball 10 millimeter and or in diameter is normally used. Next is micro-hardness testing. In micro-hardness testing, loads are less than 1 kilogram and indentation can be seen only with the aid of microscope. Crop and fakers or low-load tests are in this category. Indentures used and the identification the make are compared in this picture. Vickers indenture. Vickers indenture is a square-based diamond pyramid like in the picture A. The applied load force is generally or less. Typical impression also is shown, not indenture. The tensor operating procedure for testing the same of just for the Vickers test. Difference are the geometry of the indenture and composing of area. The knob indentation is rhombus-based diamond pyramid that provides an impression of the sweat and so in this picture and only the long diagonal is measured. Okay, next is tensile testing. Next to hardness testing, mechanical testing of specimen under tension is by far the most common type of mechanical that is performed. The properties desired from tension testing include the first is stress strain, showing the elastic and plastic strain region of the formation on the load. Two is tensile depth strength, indicating when the elastic limit is reached with some appreciable amount of plastic deformation. And three is ultimate tensile strength or UTS, defined as the maximum load F max divided by the original cross-sectional area of the specimen. Testing machines. Mechanical testing machines have been commercial availability since the late is 80. Testing mechanism. Mechanical testing machines have been commercially available since the late 80s and have evolved from purely mechanical latching such as the popular latchel giant, hand-cranked tensor tester of China's ocean Sirsa, like this picture. Okay. The cross-section of typical gear-driven system is shown in this picture. Component of electromechanical screw-driven testing machine. For the configuration, so moving the lower intermediate head upward process tension in the lower space between the crosset and the base. The screw are rotated by variable control motor and drive the mobile crosset up down. This motion can load the specimen in either tension or compression depending on how the specimen is fixtured and tested. The range of crosset speed can be expanded by varying the speed of the electric motor and by changing the gear ratio. Next is fracture toughness. If a defect such as crack were to go in the material, then the amount of electric strain energy per unit volume would be reduced because the object's load cannot be supported across the face of the fracture surface. Although the stress file in the thickness of the crack can be great compression under this circumstance. To a good information, the set area in this figure represent the region where stress exerted fall to zero due to the presence of the crack. In this region, a significant amount of elastic strain energy can be stored. The volume or V of this region is simply the area of the ellipse that existed in the picture multiplied by thickness of the material. We find that like this. Okay, V is V is 2, V8 is B, like the picture. A classic example from War II is the sudden fracture of the SS Kennedy. She was more than floating dark at Swan Island is Oregon in the calm weather. Shortly after returning from her sea trials, when the ambient air in Gibraltar had fallen to -5 Celsius without anything and with a noise that was audible for less a mile, the hull suddenly cracked almost in half just of the structure. The SS, like this picture, okay, the air scantily after a sudden fracture, you trip grow a crack that started in a hole. Next is fracture toughness testing. With the advent of linear elastic fracture mechanics, engineers now realize that design of structure and mechanics can no longer, under a condition, be based on the elastic limit or yield strength of a material. Various tests have been referred to measure the fracture toughness of salt pressing ground. Testing is normally conducted on a screwdriver or servo hydraulic machine that loads the specimen at precipitate rate on measurement of load and displacement are taken during the test. Like this picture, A is single engine natural bend or SE, and B is complex specimen, C. Next is impact testing. In an impact test, the specimen is subject to dynamic shock loading to evaluate the response of a material to rapid change in loading, such as experienced by an axle shot for a car is a so-called a standard import tester, and its operation are illustrated in when a specimen is placed in the part of the swinging pendulum. The pendulum is most bad end or fracture the specimen if it is to continue its arc. Okay, the two most common impact tests are the Corby and ISO test. They differ mainly in the manner in which specimens are held and broken. The Charby test often is done on specimen over a range of temperature because some material may exhibit a ductile to brittle transition of low temperatures. For example, only a small amount of energy is needed to fracture low carbon steel specimen at lower temperatures. Fatigue testing these three types of fatigue testing methodologies are commonly used. The first is high cycle or infinite life stress control fatigue testing. Two is low cycle or finite life strain control fatigue testing. And three is fatigue crack growth rate testing based on the feature mechanism concept of stress and K at the crack tip. Okay, each type of fatigue testing like the procedure is considered in the context of an underlying fatigue design philosophy. First is stress life or age and fatigue test for design with a high number of cycles. Two is strain life, a fatigue test for design with a low number of cycles. And three is fatigue testing of the fractal mechanism basement of measure fatigue crack growth rates. Next, common components subject to bending fatigue include flapper, type valves, and gear teeth. Because the maximum stretch is the surface, process such as sharpening and compressing that process some compressive stress and often used to improve the fatigue properties of the material by preventing or allows for plugging the time required for a fatigue curve to initiate. The reason for the definition is our method of compressing of the variable stress in a bending type. Okay, non-destructive testing. Liquid penetrant inspection is a non-destructive method used to find discrepancies that are open to the surface on solid externally non-porous materials. The liquid penetrant inspection process is shown in this picture. Okay, this currently open to the surface of a metal is located by allowing a penetration dye or return liquid to infrared. Separation is noted in the next step by various means such as sweeping, which are clutch or by washing directly white metal, treating with an emulsion and rinsing or recounting with a sulfur. Liquid penetration for the surface cracks A is an open crack ground in penetrant liquid by capillary action. D excess first penetration and moped and see the proper graph of penetration liquid and forms a visible indication of the surface strength. Next is ultrasonic testing or UT. Ultrasonic inspection has a number of dimensions, including the first is plus depth in a part can be detected. Inspection to depth of several feet is done routinely. Two is due to the high sensitivity of the process. And three is position of internal factor can be determined with great accuracy. Major limitation includes the first is operators must be well trained and experienced. Two is contact with the part surface is a liquid or semi-liquid component is selected in order to provide effective transfer of the ultrasonic beam between search units and the part being inspected first times are liquid, but for operation of the equipment and for characterization of the flows. Next is radiographic testing or RG. Involves spacing X-rays or gamma ray stroke or material to get an image of its internal structure on radiograph film or digital detector. Next is magnetic vertical inspection. It's used to locate surface and subfocus destructiveness in ferromagnetic materials. The method is based on the facts than when a material or part being tested in magnetism. Consequently, that lie and direction generally transfers to the direction of the magnetic field cues electric file from at the above a surface on the curved part. Electromagnetic yield showing position and magnetic field to detect discontinuous parallel to a volt belt. Discontinuous across a volt belt can be detected by placing the contact surface on the Yolk next to end on either side of the bed, rotating yolk about 90 from positives of yolk. Next is eddy current testing or ECT. Uses electromagnetic induction to detect surface and near surface defects in conductive materials, a coil carrying an alternating current in place near the surface of the material and change in the electromobility caused by the text variations in the eddy currents, which can be detected as analysis. Okay, I think it's I will present it. I say thank you.